Hello everybody, how's it going? That's the most beautiful venue ever, but probably every speaker will tell that. Watch your back browser, you're being observed. Let me quickly introduce myself. I'm Stefan, sometimes I look like that. Who has been at JSConf yesterday? Yeah, this is an initiative that is called Resize, so if you want to join us, feel free. It's a lot of fun, it's a very fluffy, so definitely a really cool thing. I'm a front-end developer from Berlin. I'm occasionally teaching CSS and Node, and I'm organizing the web performance meetup in Berlin. And my main focus these days is open source performance, web performance, and accessibility. And I work for a company that is called Contentful, so we are a content management system in the cloud. This means that if you need a CMS, you can simply register, give your editors or non-technical people a web interface, and you as a developer then only have to work with an API. And this is what you do anyways. And with Contentful, we always say editors get a CMS, and we as developers don't actually have to work with one, which is really, really nice. And last fact about myself is I'm really excited about conferences. Because you can learn so much stuff, and you can meet a lot of new people, you can have an excellent time, you can make new friends, and these conferences help me to stay up to date. Because the web platform today evolves really, really fast. And we have finally yearly ECMAScript releases, new browser APIs are coming out every day, and we finally have evergreen browsers, right? I'm really happy about that. And staying up to date is kind of part of our job. And I personally have a hate-love relationship with that. Because every day we're dealing with this. A new tool every week. But then at the same time, browser APIs adapt to common use cases, right? Let's think of jQuery and the dollar selector. Today we've got document query selector all, and the browser APIs are slowly moving from a pull model where we have to ask for information to a push model. And what I want to show you today is what that actually means. But first, I think we should celebrate. Because we've got a lot of cool new stuff today, and we're here. And I believe we will have 2 excellent days. So what I did is I took the JSConf Budapest website. This is how it looks like. This is the schedule. Looks good to me. But I think we can bring a little bit more celebration in there. So I spiced it up a little bit with a fancy lazy loading effect. In case you don't know that one, that's the Twitter heart animation. And I stole it from Anna Tudor, who does crazy stuff in CSS, and this is done with one element. So how would you usually achieve this kind of effect? Well, first you have to figure out if something is visible in the viewport, right? So how do you do that? Well, I Google, and then you, and then you end up at Stack Overflow. Who's guilty of copying this snippet? Come on, probably more people here. And then there's this piece of logic in there, which I'm always too lazy to think about that. But there's one gotcha with this, though. This is calling element get bounding client rect. And this function on a DOM element can trigger the browser to synchronously calculate style and layout. This happens when something changed, like adding a class or something. And this is an expensive operation. So when you use this, you should always batch all the reads and then write stuff. But this is actually not cool because, well, we have to pull for information, right? We have to ask explicitly. If you're interested what functions are good to use performance-wise, Paul Irish is maintaining this document here. And when you're doing these kind of things, having a look there is definitely a big help. So what is next then? Well, we define a scroll handler, right? Which fires 1,000 times when you scroll through a page. And there's also something wrong with that, because scroll or scroll handlers are a really expensive operation by default. And when we want to build great UIs that stick under our fingers when we play around with our phones, we always have to aim for 60 frames per second. Dividing 1 second by 60 means that we have 16 milliseconds, but this is actually not true because the browser has to do some other things than just dealing with our JavaScript. So in real time, we have around 10 milliseconds to avoid janky scrolling. This means that we want to do as less as possible in a scroll handler. So what I did next is, well, I head to my developer tools of choice, and I monitored the whole thing, right? These are the Chrome DevTools, and first thing I did is I throttled the CPU, because this device here, and we heard that yesterday already, is not your average user. Not everybody has this kind of device, and also not everybody has a latest or recent phone. And then I checked the frame rate of my cool lazy loading effect, and, well, it was not that good, right? And when we look a little bit deeper, we see that element get bounding client rect takes a big part of that. And in this example, it took actually 12 milliseconds, which means that we already hit the budget. And this is firing on every scroll frame, right? This is really expensive. So let me show you one solution to this problem. The intersection observer. The intersection observer is a method to asynchronously query the position of an element with respect to other elements or the global viewport. This means with this, we don't have to do costly DOM and style queries, and we don't have to poll for information. Using something like this helps us to reduce CPU, GPU, and energy costs to figure out if something is visible. So how does that work? Here you see an intersection observer implementation. First, you have to define a threshold. And in this case, I'm going with 1.0, which means that I want to get notified when an element is completely visible. Then you have to initialize a new intersection observer, and this is then called with several intersection entries. And these then have a intersecting property, and then I'm adding a class that is called party, and then I'm unobserving the given element, because, well, my job is done here. And then I can just grab all the elements and can tell the observer, hey, can you please watch out here? Cool. So and with an implementation like that, we see that there is no get bounding client rect anymore. And this is not called on scroll. And when we check the frame rate, we see that at least for figuring out if something is visible, we end up at 60 frames per second. I think that this is really, really cool. So when we're building these kind of things, what I always try to do is take a moment and measure it. Measure it using the dev tools of your choice, use web page tests or Lighthouse, and maybe try it on a real device, which is not a 6-month-old MacBook Pro. So what options do we have for an intersection observer? Well, we can define a different root element. We can tell the intersection observer how this is laid out. And then we can define a threshold, which is a single value or several values. And this is actually really, really cool, because when you define several values, so in this example, 0 and 1, I get notified when something enters the viewport, I get notified when it's completely visible, I get notified when it starts leaving, and when it's gone. And this is only a few lines of JavaScript. So let's have a look how this entry looks like that I get when I'm notified that something becomes visible. So here we see the viewport, and here we see what happens when the element enters the viewport. So the entry then has an is-intersecting property, which is true in this case, and an intersection ratio, which is something around 0 here. Why something? Because the intersection observer works async. So the browser figures out when it has time to figure out if something is visible. So what happens when it leaves the viewport again? We've got is-intersecting false, and then we've got the intersection ratio of 0, which makes sense because there's no value below 0, right? There was one thing, though, that surprised me. So let's go with a value that is bigger than 0. So when we have a ratio or a threshold of 0.5, so something is entering the viewport, so we again have is intersecting true, and an intersection ratio, again, something around 0.5. But when it's now leaving the viewport, we've got is intersecting still true. This surprised me initially because I was expecting it to be false, but is intersecting tells you if it's still in the viewport, right? And when we go with a threshold of 0.5, this actually makes sense. And the ratio then is something around 0.5. And with the intersection observer then, we can build really nice interfaces, like something like that. Make stuff appear or disappear when something else changed got out of the viewport. And this is 10 lines of JavaScript without Googling. I think this is really, really cool. And you can also use it for figuring out if something is visible in responsive web design. So there are a lot of use cases for the intersection observer. So how's their support today of the intersection observer? Well, it's not too bad, I would say. But there was one gotcha, though. When I started playing around with this, I discovered that there have been incompatibilities between spec and vendors, and people got together and were like, okay, we have to figure that out, because let's figure that out. But these are resolved since October 17 with the release of Edge 16. So it's now ready to go. The only thing I want to tell you is when you use this without a polyfill or something, just watch out and read maybe the issues and see if there are issues or if you run into these. But how's the polyfill? Is this polyfillable at all? It is. And the polyfill also takes care of this incompatibilities. So this is usable in production today. So we celebrated every talk here now. I think we can do more. So let's celebrate the whole schedule. Ready? In case you don't know that there's a third-party library that is called Cornify. So I highly recommend it. So now I've got the problem. The intersection observer code was wrapped in an immediately invoked function expression. So I have no idea when something changed, or there are no callbacks, no events or something. How could I now figure out that my party class was added? Well, let's meet another observer here. The Mutation Observer provides developers with a way to react to changes in the DOM. So how does that work? So here we see a basic implementation. And what I do is I grab the whole schedule, then I grab all the speakers, then I define a config object which defines that the mutation observer should watch out for attributes and the whole subtree. Then I initialize a new mutation observer, and then I get notified when there was an attribute change, and then I'm just checking if the element now includes the class party. And then I'm counting up, and if this is done, I'm calling Cornify add. And then, well, I'm just telling the mutation observer, all right, please check out or watch out for or observe this element. What options do we have for mutation observer? We can define if we want to observe children, attributes, whole subtrees, and there are way more options to define. So you can check out the spec or the MDN entry for that. How is the support for the mutation observer? Pretty green. You might not need this observer very often, but if so, this is extremely helpful. And I use Cornify here now, and I'm kind of a web performance person, and when you do something like that, what I want to tell you also is, but let's always watch out for performance, right? And measuring performance can be done in two ways. There is synthetic monitoring. This basically means that you send a robot to your site, gather some metrics, and see how you're doing that way. And there's also real user monitoring, which means that you implement some JavaScript and you get the metrics right out of the browsers or, of your visitors or users. For synthetic monitoring, in case you don't know it, really handy tool is called web page test. And what you can do there is you can enter a website, can define a connection speed, a location, and then you get metrics afterwards. If you wonder how people make these kind of compare videos of two websites to see what is loading when, this is all done with web page tests. And this also then gives you tips and tricks and a lot of useful stuff. So if you haven't used that yet, give it a try. It's a really, really powerful tool. But this is only one moment in time. If you look for constant or continuous performance measurements, tools like SpeedCurve or Calibre can help you out there. But what I want to actually talk about are real user metrics. And what we have there today is the navigation timing API, the resource timing API, and the user timing API. So let's have a quick look at what we get out of these APIs. So the navigation timing API is available via window.performance.timing, and this is an interface for a web application to access the complete timing information for the navigation of a document. So what do we get here? Well, there's a lot of stuff included. This can be really useful information if you measure web performance. There's stuff like how long did DNS take? How long did TCP take? When did DOM content load happen? All these kind of things are accessible via the navigation timing API. And then there's also the resource timing API, which is an interface for web applications to access the complete timing information for resources in a document. And you got more or less similar data there. A few entries are missing. But let's think of style sheets, right? Style sheets are render blocking resources. Maybe you want to know when a style sheet is hanging around or not loading for 3 seconds, because this is directly impacting user experience. And then there's also the user timing API, which is an interface to create application-specific timestamps. And you can measure, for example, navigations in a single-page application or something like that. So let's measure how long my cornification took. So here we see what happens when all talks have been seen. And I can now set marks. So I'm setting a mark before and right after, and then I'm defining a measure, which is the combination of both marks. How can I access this information then? How long it took? Well, there's window.performance get entries by type mark, and you see when it happened there. And by using get entries by type measure, you see how long it took. And you see in this example, it was 6 milliseconds, which kind of fits into my budget. So real user metrics right today exist. We can set mark measures. So we've got marks, measures, and navigation resources, and these are accessible via get entries by type, and get entries by name. And that's pretty cool. But this is not what we want. Because using this, we have to poll for information. We have to detect when there are new metrics. We have to duplicate logic to figure out what is new. So let me tell you the third one here, the performance observer. So this is how it works. So you have to initialize a new performance observer, and then you can define what you want to watch out for, right? In this case, it's type measure, and then you get notified. And this is really cool, because this way measurements are pushed towards me. So I also had a look at the spec then, and it was like, what was written in there? All right, developers today are encouraged to use the performance observer. All right, I can deal with that. But then there was also an interesting sentence which was like, further, new performance APIs and metrics may only be available through the performance observer interface. What new metrics are we talking about here? So there is, for example, the paint timing API. And this API gives us information, for example, when the first paint, which means any painted pixel, or when the first contentful paint happened, which means that any text, image, non-white canvas, or SVG is rendered. And this is shipping in Chrome, for example, since Chrome 60, and we're currently on Chrome 61. This is also available using get entries by type. And then there's also the long task API, which tells us when JavaScript operations took longer than 50 milliseconds. And with these kind of things, I've got the metrics right at my fingertips, right? So this is, for example, my personal website. And what you see there is that I have a local storage flag. And with this, I get the information how long something took right in my face. And then I'm also relying on the Contentful API here, so I also see how long the API calls take. But let's have a look at another example here. So this is Zalando. And what's the most important thing here? Well, I would say it's the image, right? It's 50% of the screen. So how hard can it be to measure when this thing is rendered? Well, today we have to do this. We have to define the image with an onload handler. This clears navigation timing API marks then, and sets a new mark. And then we've got an inline script afterwards. So what this basically does is whatever happens last is the right value here. But this is not good experience, at least in my mind. So there are also new specs in the making. For example, like hero element timing. This is currently really only in spec writing and discussing how we could implement that. But with something like that, we can get information when something crucial is rendered or laid out. For example, Twitter is constantly monitoring how long it takes until the first tweet is loading. And this is really valuable information. So let's see where this goes. And just for the sake of completeness, there's also server timing metrics, which the server can set via a header, and then these values are easily accessible via the Performance Observer. This only works in Canary, though, today. If you're interested in more metrics regarding web performance, there's this excellent talk that is called Leveraging the Metrics That Most Affect User Experience. Highly recommended. So, what's the support for the Performance Observer today? I discovered last week, actually, that Safari joined the party, which was surprising, though. So it's not that bad. Is this polyfillable? Well, if browser vendors at some point decide that they only want to push metrics through the Performance Observer, the journey is more or less over. But so far, the metrics are also available via get entries by type, so you can do a feature detection check, and then you're ready to go. So what we have now is a lazy loading effect. We've got unicorns, and unicorns are pretty great, but what's better than unicorns? Onesies again? Anyone? What was that? I didn't understand that. All right, I give you a hint. And now? Did I hear glitter? All right, so I'm from Berlin. I'm mostly into indie music, but I also like electronic music, and a good open air, sunshine, good music, dancing, just forgetting the day is perfect to me. So what I implemented next was confetti. And to do that, I had to cheat a little bit, but I think that's all right. Let's assume there's a slide up and down thing in the website. This makes me really happy. So how could we now figure out if something changed its size? Any guesses? Well, there's also the Resize Observer. So how does that work? So we have to initialize a new Resize Observer, which then gets called with several entries. And then we're just telling, hey, all right, can you please watch out for these elements? Cool, I want to do something. I want to draw confetti then. You might ask yourself, though, okay, Stefan, but when is this firing? The Resize Observer fires when elements get inserted and removed from the DOM, when they get set to display none. They are not triggering on CSS transforms, though. And with this information, well, I have to tell you, my implementation was broken. So it triggers on on load. That's not so cool. It's triggering on closing. I mean, confetti is great, but that's not really accurate here. And it's also triggering on horizontal resizing. But I think it was okay at that point, right? So when could we use the Resize Observer? Well, for drag and drop interfaces, this can become really handy. This is 6 lines of JavaScript, and I can maybe adjust scroll positioning or something like that. And we're all waiting for element queries, right? Maybe they will be there at some point. The JavaScript implementations of Polyfill for this are also considering using the Resize Observer to figure out if something changed its size. So how's the support of the Resize Observer today? Yeah. We're entering cutting edge here, I would say. Is this polyfillable and usable in production? I would say so. There are polyfills for the Resize Observer out there, and these use mutation observers, and they're not covering everything. So you might want to consider if you really want to use that today. But I was still not really happy, so let's face the resize problem here. And let's take a step back and let's see what we're actually dealing with. So here we've got an element, and this is a simplified version for one element. So what are we dealing with? We're dealing with this initial call, we're dealing with several opening calls, and we're dealing with several closing calls. And what we actually want to do is we want to get rid of the first one and of the closing ones. So how could we do this? Well, here we have the callback that is triggered on resize. So, well, we could store a Boolean and toggle that. And how could we figure out if it's getting bigger and smaller? Well, we could store the last run and then compare. But this code for me is not really readable, and it's also hard to maintain. And it has side effects outside of the event handler. And if you have several entries, that gets more and more complicated. So let's enter the final topic, observables, just because the name is fitting. Observables are a collection that arrives over time, and currently they're only in spec, but they have already a widespread usage thanks to Rx and libraries like that. And they're definitely a talk on its own. So again, observables are a collection that arrives over time. So let's have a look at an observable implementation. So here you see a function that is called getObservable with 3 values. It's initializing a new observable, then it's calling next and pushing values into this collection, and then it's completing at some point. Then we're defining handlers for given events of this collection, and then we just subscribe to that. And then we get next 1, 2, 3, and yeah, we're done. When I saw this for the first time, I was like, what's the deal here? That's just shifting around callbacks, no? But now, we're dealing with a collection, which means that we have stuff available that like map, filter, reduce. And this makes it possible to write ray cleaner code. So this was the initial implementation, and let's change that to use, for example, something like Rx. And new observable becomes Rx create here. And what I now have is a collection of events over time. And this gives me collection superpowers. So let's have a look at the timeline again. So this is what we're dealing with. And I'm calling getResizeStream here, which gives me this collection that arrives over time. How can I get rid of the first one? Well, skip it. Cool. How can I figure out if it's how the last run was? Well, there's a function for that, pairwise. Cool. How can I not drop the closing ones? Filtering, maybe? And how can I get rid of the previous ones now? Map it back, and then call the stuff that I want to do. This is pure functional code without side effects. That's easy to read, maintainable, and testable. I really, really like that. So with that, my implementation was bug-free. Woo! So what we talked about was the intersection observer to figure out if something enters the viewport, the mutation observer to figure out if something changed in the DOM, the performance observer to not ask for metrics but rather get notified, the Resize Observer to figure out if something changes its size, and Observables, which are a completely different way of thinking. And it takes a while to get it. I'm still figuring things out with Observables, though. And I'm in the web development industry for 7 years now. And oh well, so much has changed. And web development is still fun. It's probably one of a big love in my life today. But yeah, we all have to admit, and probably all know, that so much will still change. And even if it's exhausting, I really, really love that. And yeah, we're all here in this really beautiful venue, and we have really good times. So let's all celebrate. Are you ready?